Okay, so we're looking at natural domain in this lesson. And so this is sort of a tack on like domain and range. It's a very common like HSC question. And we're going to look at a few things. I don't know if this learning goal makes sense, but we've got to use knowledge that we can't divide by 0. If you don't believe me, ask Siri what 0 divided by 0 is, and she'll really offend you. So, but you can't have anything on the bottom of a fraction that's 0. Okay, you can have a 0 at the top of the fraction. Not so you can have anything at the bottom of the fraction. You can have that. That's fine, but you can't have it at the bottom. Also, because we're using the real set of numbers, we're not up to imaginary numbers or anything like that. You can't square root any numbers that are negative, and so we're going to be looking at that fact too. All right, let's get on to examples. Okay, find a domain of the following. So let's look at question 1. Okay, I know that x can be any number except 0. All right, so my domain will just be x cannot equal to 0. So that's saying that every other value of x is valid, because if I put x as 0, I can put 1 over 0 and that won't work. That's real bad maths. Okay, so that's the domain of that one, natural domain. Now the second question is very similar, but it's just going to be another number. Like, what number of x will give you this? Will make the denominator 0. If you said 3, you'd be 100% correct. So x cannot be 3. Now, if you wanted to work it out, just solve for 0. So get x minus 3 equals 0, x equals 3, and that way you know, okay, because it's all about what makes the denominator 0. So that's why we made it equal to 0. Now, number 3 and 4 are really closely related, but I put them both as the same example. Like, they're not the same example, they're two very different numbers, but like both of these are x plus 2, because instead of doing the sum over again, we can see the slight differences of having square root by itself and a square root at the bottom of the denominator. So with this number 3, I know that whatever is underneath this, I'll use another pen, whatever is underneath the square root has to be positive, because we can't square root negative numbers. Try on your calculator. One thing we can do is that we can actually square root 0. Okay, so I can write my domain, well, or process to my domain, that saying that x plus 2 has to be positive, so it has to be greater than 0. Okay, but because it can also be equal to 0, I'm going to put it's going to be a greater than or equal to 0. Okay, now I can just solve for x. Therefore, x can be greater than or equal to minus 2. If I move this to the other side, I get minus 2 over there. So my domain, so I can write it natural domain, if I make this f of x, that's not f of x, of f of x is, and it's this thing here, x is greater than or equal to negative 2. Okay, I'm going to make this bottom one g of x, so it goes with our function topic, because I just want to make a distinction between them both, and I'm probably going to use another coloured pen, and I'm going to put a straight line here so we can get going. Now, what about the one in the bottom? Well, it's exactly the same, with one difference. If we go back to this one and this one, is that if we can't have 0 at the bottom of a fraction or in the denominator, but in this one, it was okay. We could have 0. So the only difference is that this number here, x plus 2, it does have to be a positive number because it's underneath this square root, but it also has one more condition: it can't be 0. It has to be greater than 0. So we can say, therefore, natural domain of g of x is, and it's going to be the same thing except without the equals, x has to be greater than -2. Okay, so we can see that quite clearly. And if you, what might be interesting is if put these into Desmos and see what you get. Okay, I think you might find some interesting things about the domain. Anyway, that's the lesson on natural domain. So.